Welcome to the notes on equivalent rational expressions and least common denominator. Remember, equivalent, all right, that means equal. So equal rational expressions. And the least common denominator, remember, that's really the least common multiple. All right, so you guys will hear me say that a lot. All right, to find that, that's what you need to find. So if we look at this one right here, all right, find the least common denominator. You have two fractions. You want to come up with that common denominator. To do so, you find the least common multiple. And remember, 4 and 9, if I want to find the multiples for those, all right, 4 times 1 is 4. Again, it's different than factors. It's not numbers that divide a number, it's numbers that they multiply into. So 4 times 2 is 8. We got 4 times 3 is 12. 4 times 4 is 16, and so on. 20, 24. I'll just list out a bunch of these. 28, 32, and one more is 36. Okay, then 9. 9 times 1 is 9. 9 times 2 is 18. 9 times 3 is 27. Sorry, I'm getting ahead of myself. And then 9 times 4 is 36. Now you can see that the least common multiple is 36. And a good way to come up with a common multiple, and I use this as examples because a lot of times what you can do is you can just multiply the two denominators together and you will get the least common denominator, which again, in this case is 36. So that really helps us when we're doing some of these examples we'll see in a second. So now for this one, all right, you want to look at the numbers first. All right, the least common multiple of 5 and 15. All right, well, 5 multiplies into 15, and 15 times 1 is 15, right? So 5 times 3 is 15. 15 times 1 equals 15. So we know that 15 is the least common multiple. Now, for the exponents, it's always going to be the highest exponent. I'll just put EXP because x can multiply into x squared. X squared cannot multiply into x. So it's going to be the highest exponent. So this would be 15x squared. Okay. So now, some other couple examples. All they want you to do in this section is just to find the least common denominator. Now, when there's not numbers, when it's written like this, we just have an x plus 2 and an x minus 2. To come up with the least common denominator, you're just going to multiply them together. So the least common denominator, this one would be actually x plus 2, x minus 2. Well, how did I get that? Well, this side has an x minus 2, right? But so it needs the x plus 2. Now it actually multiply top and bottom by x plus 2. And then this side over here needs the x minus 2. X minus 2. So you can see my least common denominator would be x minus 2, x plus 2. So for these, you're just going to kind of combine those. Same with this one. This one has an x. This one has an x plus 4. So my least common denominator would just be x times x plus 4. Because this side needs the x and the x. And this side over here needs the x plus 4, x plus 4. See how that works? Okay, so we're just going to combine those together. This one's a little bit different because of this one right here. Hopefully you guys get used to seeing these. We don't want the number listed first. We want the exponent list or the variable listed first. So we're just going to switch order. I'm going to do that up here. So I'm actually going to say negative x plus 2, right? I just switched these and these. Okay, but now I don't want this negative here. So how do I get rid of it? I'm going to factor out a negative 1. All right, so I factor out, then I'm left with x, and then that changes that plus to a negative sign, so x minus 2. Now when I compare this to this, I can see that we need the negative 1 to each side. So I multiply this side by negative 1, or I bring it to the top. My least common denominator is going to be negative 1 over x minus 2. So hopefully you guys can see how we're going to kind of combine those to come up with least common denominators when there are no really numbers. It's just expressions. Okay, this next section is write each rational expression as an equivalent rational expression with the given denominator. So what you're going to look at is you're going to look at the denominators. How did I get 4 and I went 216? Well, I must have times it by 4. So since I multiply the bottom by 4, I have to multiply the top by 4. So I'm going to multiply 3 times 4 and I'm going to get 12. So that's how you would do that. Again, because when I have to multiply top and bottom by the same value, because 4 over 4 equals 1, and when you multiply by 1, you're not really changing the value. So that's how these work. Okay, this one here, all right, what did I multiply from 9a to get to 27? Well, I must have times it by 3, and I went from a to a second, so I must have an a there. And this one has a b, and this one doesn't, so I must have multiplied it by 3ab. Well, then I need to multiply the top by 3ab as well. So my final answer would be 12ab squared. There you go. This one here, okay, what you always have to do is factor first. Anytime we're coming up with the least common denominator, all All right, we have to factor first because how do I get from 2x plus 5? This one you might be able to see it, but it's a lot easier when you factor it. So I'm gonna take out a 2 from, or excuse me, a 3 from 6x plus 15. Well, 3 times 2x is 6x, and I factored out 3, so I still have the plus 5. So now you can see the only difference is I multiplied this times a 3. Well, since I multiplied this by 3, I have to multiply the top by 3. So my final answer would be 21x. There you go. Okay, one more. Again, have to factor first because how do we go from here to all of this? I don't know. Well, let's factor this first and find out. X squared minus 4 would actually become, oops, I'm going to read it over here, would actually become x plus 2, x minus 2. It's the difference of perfect squares. And then you can see the only difference, here's my x plus 2, x minus, is this x minus 4. So I must have to multiply top and bottom by x minus 4, and I multiply this one by x minus 4. So when I do that, all right, that's really going to equal 5 times x minus 4. You can write it like that, or you can distribute that. You can equal 5x minus 20. So either one of those answers would be correct. So that's how you find least common denominator and equivalent ratios.